Okay, so first it starts out with Pythagorean theorem questions. So the first one, we're going to use Pythagorean theorem. Pythagorean theorem, which is a squared plus b squared equals c squared. Now I'm going to kind of race through it because this should be pretty easy for you guys. So this would be a and b, and then this is c. So we get 20 squared plus 21 squared equals c squared. 20 squared would be 400. 21 squared is 441 equals c squared. So then you get 841 equals c squared. Take the square root of both sides, and you get c equals 29. That feel better? Yes, okay, great. Next one. Next one's Pythagorean theorem as well, but in this case, we're not solving for c. We have a and b here, and they give us c, so we're going to solve for b now. So we have 11 squared plus b squared equals 12 squared, and we'll solve for this missing side. 121 plus b squared equals 144. Subtract 121 from both sides. B squared equals 23. Square root of both sides, and b equals 4.8. So it says to round to the nearest tenth as well. So when you do 23 square root, you get this number, which would be 4.8. Okay. Next one, find the area of this right triangle. Be sure to include the correct unit in your answer. So area of a triangle is 1/2 base times height. So this would be the base, and then this would be the height. And then you need to solve for this side length, and you can use Pythagorean theorem. So we'll do a squared plus 8 squared equals 10 squared to solve for this base length. Subtract 64 from both sides, we get a squared equals 36. Square root a equals 6. And so now that you have the base, you can plug it into this equation. 1/2, the base is 6, height is 8. And then you can solve, either plug it into a calculator. 1/2 of 6 is 3, and then 3 times 8 is 24. So the area equals 24 centimeters squared. Okay. Then we're going to go up to the top right. Still using Pythagorean theorem. For these problems, it wants you to use the side lengths to determine whether you have a right triangle, acute, or obtuse. So if a squared plus b squared equals c squared, it's a right triangle. If a squared plus b squared is greater than c squared, then it's an acute triangle. And then if a squared plus b squared is less than c squared, it's an obtuse triangle. Sometimes I forget or get these messed up, but if you think about it logically, like an acute triangle would look like this, and like a smaller angle would mean a shorter side, whereas an obtuse triangle like this with a larger angle would mean like a larger side, which makes sense to me. Okay, then from here, it gives us the 3 triangle side lengths. The 2 shortest would be your A and B. So 5 squared would be 25, 12 squared 144. Add those 2 values together, you get 169, 169, 169. And then 13 squared is 169. And so since 169 equals 169, it's a right triangle. Next, over here, again, here's the side lengths 8 and 6 would be the two shortest sides. 36 plus 64 is 100. 11 squared is 121. So a squared plus b squared is less than c squared, so it would be obtuse. Okay. Then this one here, the title of this is Use Pythagorean Theorem Repeatedly, which clues you into what you're going to do. So it asks for this length here of EH. And so what we're going to do is find this length first, and then we can use Pythagorean theorem to find this one. So we have two sides here. We can do a squared plus b squared equals c squared to find this length. So a squared plus 84 squared equals 105 squared. 84 squared is 7056. And 105 squared is 11,025. Subtract from both sides. A squared equals 3969. Square root, and a equals 63. So that's this length. And then once you have this length, you can solve for EH. So we have a squared plus b squared equals c squared. 63 squared is 3969. 65 squared, 4225. And a equals 16. Okay, the next section is special right triangles. So only 2 questions on special right triangles. Special right triangles. So remember there is a 45, 45, 90 degree triangle. And for a 45, 45, 90, the 2 legs are the same length, and then the hypotenuse is x times square root of 2. And then there's the 30, 60, 90 degree triangle. Looks like this. You have your short side, 2 times the short, and then short square root of 3. Okay, so there's 2 different problem types here. Here it says round your answer to the nearest tenth, so it wants a decimal. And then over here it says leave your answer in simplified radical form. Okay, well, we'll start here with the 45, 45, 90. If this is 7, then to get here we have to multiply by square root of 2. So you get 7 square root of 2. And then in a calculator, just 2 square root times 7 is 9.9. If needed, with the decimal ones, you could use trigonometry. You could use SOHCAHTOA. Like from this angle, you have adjacent hypotenuse, and you could use that to figure that out if needed. And then this here, 30, 60, 90, we're going to need to figure this out first and then times this by 2 to get this. So from here to here, we're going to divide by square root of 3, get 4 over square root of 3, and then times by 2 to get this. So 2, 4 over square root of 3. And then from here, see, 4 divided by 3 square root equals times 2 is 4.6. And with the decimal ones, you could technically use trig. Like from this angle, you have opposite hypotenuse, and just go from there. Then over here, it wants you to put the answer in simplified radical form. So from here to here, we're going to divide by square root of 2. So 7 over square root of 2. You can't leave it in this format though with the radical as a denominator, so we multiply by square root of 2 over square root of 2. And then you get 7 square root of 2 over 2. That's the answer there. And an easy one for the last one, which is nice. To go from here to here, we multiply by square root of 3. We get 4 square root of 3. Then it gets easy again. Okay. The next section starts trigonometry. Use these lengths to find cosine of L, tangent of L, and sine of L. So we're making an arc at L. So first step, make arc at L. Why L? Because of, L is the designated angle. Then you're going to label your sides and label them in order with opposite, hypotenuse, then adjacent. So from here we have opposite, hypotenuse, and then adjacent. And then from here, we can make the ratios just using SOHCAHTOA. Just jot it down so you have it as a reference. And then cosine is A over H, so that would be 4 over 5. Tangent is O over A, 3 over 4. And sine O over H would be 3 over 5. And the next one's pretty easy too. It says use the Alex calculator to evaluate this expression. Round your answers to the hundredth. So that'd be 2 decimal places. 2 decimal places. Okay. So in the calculator, you can just do 67 sine to get the decimal and just write it down. 0.92. 16 cosine. 0.96. And 55 tangent. 1.43. So we can use calculator. Okay, we're flip the page over. Almost done. Yes.
Well, the hard ones that we learned today, will not count on the practice test. Actually, right.
On the practice test. Yeah, I won't make them count. Next. Okay. Then here we're going to use SOHCAHTOA on this to find this missing length. One more thing I want to make you aware of. Here it says angle of elevation. That's part of the standard too, is for you to understand both angle of elevation and angle of depression. So I'm just going to draw you a quick little picture. So here's like water or grass, however you want to think of it. Here is a cliff. And here is a man standing on this cliff. Okay, so from the grass or the water, there's like a line of sight up this way. This is called angle of elevation. And then there's also angle of depression. So if his line of sight straight this way, like down like this, would be angle of depression. And so those are the two things. On Alex, they give you a picture each time, so you don't really have to worry about it. But if you ever had a question like this on SATs or something where there's no picture, that's what it is. Okay, so from there, for this problem, we are going to use SOHCAHTOA. SOHCAHTOA. So you have our angle right here, and then opposite and hypotenuse. With OH, we're going to use sine. So sine of 42 equals, so say 75. 75 over x. So this would be the more complicated problem where x is a denominator. So to get x by itself, we start by multiplying both sides by x. Get x sine of 42 equals 75. Then from here, divide this sine of 42, divide this sine of 42. Get x equals 75 over sine of 42. And then in the calculator, 75 divided by 42 sine, and then hit equal one more time, and it gives you the answer. Here, it's 112.1. Okay, next one, pretty easy, find x. So from this angle, we have opposite and adjacent, O and A, so that means we want to use tangent. Tan of x is opposite over adjacent, 15 over 10. To solve this, we have to use the inverse, so tan to the negative 1, 15 over 10, or like second tan in the calculator. So just do 15 divided by 10, and then second tan, and it'll give you the answer, 56.3. That's degrees. And next, here we have opposite and adjacent from this angle. So again, we're using tan. Tan of x is opposite over adjacent, 128 over 191. Use inverse when finding angle. So inverse would be like sine to the negative 1, cosine to the negative 1, or tangent to the negative 1. So tan to the negative 1, 128 over 191. Again, second tan. And it comes out to 33.8. And then here is the work. It's the last two for my video. There. Okay. Okay, I'm gonna check. Also